this guy literally painted Jupiter. They use it NASA has one of the biggest green screen studios in the world. Why? And if you talk to people at NASA, we've talked to many of them, and they say they don't know what the person next to them is doing. Everything's so compartmentalized.
Interesting.
They say, you stupid flat earthers have an answer for everything. They call us flat tards. I try not to call them globe tards, but I know it's the thought that counts.
Welcome to the New Age Human Podcast, where we explore innovative ideas in science, spirituality, and alternative health to help you unlock your true potential and create positive change. If you're ready to transform your life and discover new possibilities, hit that subscribe button and never miss an episode. Now, with that said, let's get to the show. All right, let's go. We got Flat Earth Dave on the show today. And I'm going to give you a little bit of a background, just a teeny weeny bit. We're going to go into a lot of that subject matter. So David Weiss, also known as Flat Earth Dave, prominent figure in Flat Earth community. He's known for his appearance on various podcasts and YouTube channels like this one. And obviously we're going to discuss Flat Earth and those theories. Flat Earth versus globe. Welcome to the show, Dave. How's it going?
It's going great, John. Thanks for having me. It's going to be a fun conversation. I love talking to people that think we live on a spinning ball in a space vacuum. I find it fascinating. I find it unbelievable, but I also find it fascinating and fun.
So the irony of unbelievable, because you have most of my friends, it's unbelievable to think about flat Earth. But mind you, we don't have too many conversations about it. So
that's amazing. Yeah.
Right.
Real quick, when you mention flat Earth to a regular, everyday person, that's the crazy one. The crazy one is the flat Earth, right? That's crazy. And then when you start getting into the conversation, like you and I had, we met at a mutual friend's party. You start realizing that the ball belief, you don't know why you believe it. And when you start getting into that, it starts unwinding, And listen, I'm not saying I'm going to convince anyone here that the Earth is flat. I'm just going to make you think about some things, and you're going to convince yourself.
You know what? I have to share this. So I'm like preparing for this show. I told the group chat for the show, I'm like, hey, I got Dave coming on. If you're familiar with him, if you have any questions, I want some good, heavy-hitting questions to really challenge this guy. And
I love it.
The people that were the most active skewed towards flat Earth. So I'm like, wait a minute, guys. I need good questions.
That's my problem. I've done 12 to 1,300 interviews since 2021.
That's
2020.
insane.
Yeah. And it's getting harder and harder to find people that still 100% believe the Earth is a globe. I either got people that say, oh, yeah, it's definitely flat and stationary. It's obvious. And other people that says, I'm not sure. And I'm not sure is actually the best place to be. Because I'm not sure what this place is. I know it's not a spinning ball in a space vacuum, okay? And so it's getting harder and harder. And just as you were pointing out there, case in point, that, the people that are chiming in are already there.
Yeah, exactly. So I'm like, oh man. So I mean, I definitely have some questions, some common like arguments for the globe. I mean, there are some ones that. So I wrote out a list, and I'm like, oh, I got him. Okay. Well, what about this? Oh, I got him. And then I'm listening to your episode yesterday. I had a lot of driving. I think I drove like for 2 hours, just in general. And I'm like, all right, let me get him on one of these interviews that are most recent. And so I got the list in the back of my head, and I'm waiting for you to go over that question. And you went through like maybe a handful of them, and there's so much going on in the dialogue that you just mentioned one or two things. I'm like, okay, we're going to go into that a little bit more deeper. And then one of them, you started to explain. I'm like, crap, I don't know what I'm going to ask now, because the list that I have for you started to shorten. So for anybody listening, I'm still going to go over those questions because I'm sure you haven't reviewed it yourself. Most of us that I know of, my close network of friends, haven't gone as deep as I have in the past week, let alone like Dave in the past. Like how long have you been like doing interviews? Since like 2020?
Well, I mean, I've been into flat Earth since 2014, so it's a decade. But I really started doing interviews in 2020.
Okay.
And and then I picked up the pace in 2022, and here I am. Here I am.
Oh.
We're at, by the way, we only have 90 minutes today. I already accept your invitation to come back again.
Right. Oh man. I guess in like the shortest way possible, because I want to get into these questions. What were you always a flat earther?
Hell no, man. We're all born. Well, I think when you're born, you're a flat earther. When you're in the delivery room, you're a flat earther. Then they they inject you and they do all sorts of stuff and they commoditize you and they do all that and then they send you to indoctrination camp and you become a globe earther before you even know what you are. And they're pushing, the globe is pushed in everything. Before you can talk, your parents have a mobile over your head with the planets, and you have NASA sheets probably and NASA pajamas, and then the NASA's on Disney. And every movie, every television show, Sesame Street, has astronauts on it. It's like, what is going on with all of this? It's dinosaurs and astronauts and, and nuclear war. All right? All of that is fake. All of it. All of it. So I wasn't until 2014. I was doing a podcast called Deep Inside the Rabbit Hole, looking into all of the deceptions, New York, Connecticut, Boston, all of those things. And people started, hey, Dave, in the third year of the podcast, people, it was a big podcast, and people started sending me stuff going, hey, have you looked into flat Earth? I was like, oh, that's funny. Delete. And, and then it come again. I'm like, you're an idiot. And then they keep posting on our wall. I'm like, you're banned. Banned for life, banned for life, banned for, it's getting worse and worse. More and more people are sending stuff. And I refuse. And then I was talking to a fellow researcher, Sophia Smallstorm. If you know who she is, she did 9/11 Mysteries.
That's an awesome last name.
Yeah. Well, she, incredible researcher, very smart. And we were talking for an extended phone call, a couple hours, and about some crazy, fake false flag events that were happening. And I said, it's so amazing how much deception there is in this world. And she goes, oh, David, it's worse than that. And I'm like, what? She goes, I think the Earth might be flat, right? And I'm just like, bomb. I'm like, are you freaking kidding me? Not you too. And then she was the first one that I said, all right, let me see what you're talking about, right? Because I refuse to watch a 1-minute video. It's too stupid. I don't have time for that. There's too many other things going on. So she sends me this video, and I went in not as an open researcher. I went in as, I'm going to debunk this and put this flat Earth nonsense to bed and prove the globe. And that's it. That makes sense. The Earth is obviously a globe. And for 2 weeks, I didn't sleep, man. I'm looking. And back then in 2014, YouTube would feed you. Oh, you like that? Here's another video. Here's someone else. And they'd feed you all of the good stuff, right? And again, YouTube has everything on it. YouTube is like life. There's idiots, there's geniuses, there's nonsense, there's humor, there's everything. It's like life, right? Yeah. You have to sort it out. So it's just a depository for information, and then you sort it out. So I'm going through this stuff. After 2 weeks, I'm like, there's definitely something wrong with the globe. And then I kept it quiet for, I forget if it was like a month or even 6 months. I forget the timeline. I didn't want to talk about it on the podcast because I was afraid we're just going to lose our audience. We have a huge audience. If we bring that up, I had a hard enough time bringing up, the event that happened, 11 days after the beginning of September, and I finally realized I have to bring this up. And I brought it up, and it kind of turned into a whole thing. And after about a year, the whole podcast blew up because my co-host, one of them, just couldn't handle it. And, we went 3 years and whatever. And then I started the Flat Earth podcast. And because there was no podcast out there dealing with Flat Earth. There was tons of videos on YouTube and everything. And that took off also. So, but now I just go on other people's podcasts and talk to people like you, and I don't care the size. I'll do small podcasts, medium podcasts, large podcasts. I was just on Roseanne Barr. We're almost at 400,000, between her platforms. Probably
that's
even
right.
More
you flew out for that one.
Yeah, I did. YouTube's about to hit 100,000. Rumble's about like 360,000 or something like that. And then nice. her audio podcast is even bigger than both of those combined. So it's reaching people. If you check out Roseanne Barr's podcast now, in the background they have my compass. They have my. I gave them a wall compass.
Oh, they're
and-
committed.
No, they love it. It's actually a beautiful a beautiful compass. Let me see if I have it here. Yeah, this right here.
Oh, okay.
It's a metal cutout, and on the flat Earth. We'll just go here, and then I'll go back to you.
Yeah.
North is at the center. If we're looking down at the flat Earth, north is at the center. East and west are circles around the magnetic center, and south is every direction away from north. Okay, that's not much different on the globe, right? East and west are circles around the North Pole.
Sure.
Does it make sense? Does it make sense?
It makes sense though. Yeah.
Okay.
I'm just messing with you, but yeah.
Yeah.
That compass helps a lot. So anybody that's listening only, it's go to YouTube, but it's a circle with the north in the middle, and then all where instead of where you would normally see north, south, east, west, it's all S's. It's all south. So north in the middle, and then south is just anything away from the center, which is just an interesting way to look at it.
Every straight line is south. Isn't that interesting?
Yeah, it's just freaky. All right, I want to get into some questions.
Yes, absolutely.
So since we brought up that map, the first thing, I'm just going to go with my intuition. The first thing that pops up to my mind is my wife is from Ecuador, and so we went to the equator, Ecuador. And we went to the line in the middle.
Oh, boy.
And on one side, and they demonstrated it, right?
Yeah.
Again, I have friends that, globe and flat. So I'm constantly exploring and questioning things. So I enjoy living in the unknown. So, we balanced an egg on a needle. On one side, she, poured the water out. It spun one way. On the other, she poured the water through like this whole thing. It spun the opposite direction. And in the middle, it just went straight down. So how do you explain that?
Yes.
The cyclone, right? We have different storms based off of this. You have cyclones, I think, in the southern hemisphere for the globers. And do you call them globers or?
I call them. They call us flat earthers. I call them globers.
Okay, got it.
Okay.
Yeah.
So I try not to call. They call us flat tards. I try not to call them globe tards. But I know it's the thought that counts. So take it how you like it.
It's just fun. Yeah.
Yeah. So the whole thing at the equator with the guys pouring the thing in the water on 20 feet on one side of the equator and the other equator is stupid. It's a trick. They're pouring the water in on one side of the drain, and then they pour it in on the other side of the drain. You could do that in your own sink. Excuse me. I did it I did the same thing in my sink in my kitchen without moving and made it spin left, made it spin right. It's the same trick. And that's all it is. And if you look at the one that goes down the middle, it's just a parlor trick. And they want you to believe that the earth is spinning underneath the water, which is why it's doing that. But snipers don't use Coriolis. They claim that they do. Balloons float up, and they don't use Coriolis at all.
What's Coriolis?
Coriolis is that's the effect that's making the water spin.
Got it.
That's the effect that's making the water spin. So I have an app at flatearthdave.com, and this is because it bypasses all the Google censorship. It gives you all the information. But if you click the question mark button, that's the frequently asked questions page. And you go down to where it says, where's my Coriolis button? It says Coriolis somewhere. Oh, there it is. Coriolis is right there, right? If you hit Coriolis, it has a whole bunch of videos explaining what I just showed you and showing you demonstrations of how silly the Coriolis effect is. It's amazing. One of my favorites ones is this one by my co-host, Matt Long.
What's it called?
It's called Tennis. Excuse me. Tennis proves the flat Earth never spins. Whatever. I don't see the whole name of it there, but it's hysterical. It's actually a very funny video. So that's where you can learn about it. And as far as storms spinning in opposite directions, now that's supposedly by Coriolis. But what it is on the flat Earth map, and for those of you, I'll try to describe what's going on here. The sun circles around in between the Tropic of Capricorn, which is this outer yellow line, and the Tropic of Cancer. And so the sun and the moon travel this path around. Let me speed it up so you can see. All right. And they're electromagnetic. We live in this electromagnetic world. This is a much deeper conversation. And it's pushing an electromagnetic wake, a flow, if you will. So if you put your hand or a paddle, push it through water, you get counter-rotating vortices on both sides.
Oh my God. He actually had yeah, that makes sense. I mean, I do believe in, and I've dabbled a little bit in that research with the the electromagnetic world. I love that because that's where a lot of like aircrafts and anti-gravity comes from.
And we need to talk about gravity, somewhere in this conversation, because
Let's go next. That's the next one. Let's go.
You can. So that's and here's the thing: don't believe anything I tell you here. I'm just showing you a whole bunch of stuff that you never knew to ask the questions, and I'm showing you where to find the answers. And it's up to you. Belief is the lazy man's knowing. Okay, I stole that from Crow 777 Radio. Great podcast. He says belief is the enemy of knowing. I changed it. Belief is the lazy man's knowing. Where do I live?
Connecticut.
Okay. Do you know that for a fact, or do you believe it? I could
know
live in
that
New York.
based off of you telling me.
Yes, because so you believe it. You don't know it, right?
I'd have to stalk you and go to your house.
Right.
And be
And
like,
you know
okay.
what? If you had to know everything in your life, every interaction, if you had to know everything, you would never get anywhere. It's like, like you'd have to research everything. Like you could figure out where I live. It would take you a little time. Go on Facebook, look at some pictures, find my high school, and like in an hour, you'll be like, yeah, I'm 99.999% sure he lives in Connecticut. Perfect. No one's going to do that, right? We have to go on belief, and that's how they have us. They put a guy in a lab coat with a bow tie. He'll tell you that let's go over the horizon. That's why they disappear from the bottom up. Blah, 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 blah. And then you just believe it because that's you're told from somebody who supposedly has authority.
Yeah, and I want to add to that.
Yeah,
I agree because you would have thought, and there's videos in the past where they record people. I think it was like the 70s. They're like, oh, what do you think it's going to be like in the future where we have all this technology and whatnot? And some people thought that we were going to have all the time in the world because we're going to have all these robots, and now we have AI, and we're going to have all this extra free time to do research. And for some people, yes, but for the many, with a lot of the death grip that we have financially, socially, and just a lot of division, is getting worse and worse and worse. So it's getting increasingly more challenging to do the research. So I agree with you 100%. But there are people like yourself and myself that do some research and do our best to put it on some type of medium with the hopes that it won't get censored. And in your case, you created an app. So, there's a reason for everything. So I agree with you wholeheartedly.
And full disclosure on the app. By the way, the trolls will show up in your podcast and the comments, and they'll be like, Dave's a grifter. He's just trying to sell his app. He's trying to dumb down the world. But the app's $3, by the way. And it gives you 95% of the stuff in the app is included in the lifetime $3. But there are advanced features like messaging people, profiles, a matchmaker, a meetup maker that require an $11 a year subscription. I couldn't make it any cheaper. $11 a year.
Yeah. So you can, when you're going on a date, you can skip the flat Earth conversation.
You can listen. We have. I'll show you. There's almost we're pushing 200,000 people on the Friend Finder, and they're all smart, where they didn't stick something in their arm when they were told to. And they're all open-minded, and they're all beautiful people. So you have more in common with them once you understand what this place is than anywhere else. So where we go? You have a question? All right, gravity. So flat earthers are crazy because we think down is down for everybody. We think when we hold a plumb bob, it's the same as every other plumb bob on Earth. A plumb bob, plumb bob is a string with a weight on it.
Okay.
Right? A string with a weight. That's how they determine vertical when they're building a building. They hang a string with a little metal weight with a pointer on it, and they can get the exact vertical. But on a globe, it's not the same. Flat earthers are crazy because we think all plumb bobs are vertical, right? Globers say we're crazy because all plumb bobs go in every different direction depending on where you are, and there are no parallel lines on a globe. Globers say no two lines are parallel.
Okay. Based off of that, correct.
Yeah. So everyone's standing, people 12,000 miles away from us are standing antipodal to us. Their down is our up, and our up is their down.
Right, the old saying of digging the China type of thing.
Yeah. We're spinning, right? So think about centrifugal force of spinning. We're going 1,000 miles an hour at the equator, right? So you're standing on the equator. Okay. What if you're standing halfway between the equator and the North Pole? Wouldn't that spin kind of make you tip over? Wouldn't that spin kind of make you tip over? Think about the centrifugal force of that.
When you're in a car, you don't feel the car moving though. You only feel it when it stops.
Yeah, but you're going straight. No. When the car takes the slightest turn, you feel it. Right?
Yeah.
So when you're going, whether you're going a mile an hour or 1,000 miles an hour or 1,000,000 miles an hour, going in an enclosed system in a perfectly straight line, you can make the argument that you wouldn't feel it. But take the slightest turn and you're going to feel it. The SR-71 Blackbird goes 2,300 miles per hour. It's like Mach 3.2 or something like that. And when it's going that speed, it cannot turn. It cannot turn left or right or it'll break apart. Okay? But somehow it's nosediving down at 80 stories per second to follow the curve of the Earth.
And you're saying that the natural force of gravity won't assist with that?
No, right. Natural force of gravity. I mean, first, what natural force is that you're referring to? Is gravity? Gravity is not even a force, and it's actually a theory, and they can't even prove it.
Yes, there's a lot of theories right now that are being debunked, which is we're living in an exciting time. Correct.
I certainly
believe you on there. Yeah.
So in the flat Earth world, we live in this. Everything is everything has electrostatics. You do, the air, everything. Right. The ground has a negative charge, and the sky has a positive charge. Testable, measurable, scientifically provable. The sun and the moon are the anode and the cathode. The salt water carries the current. And the land is a salt bridge. It's a giant battery. So we live in this giant battery. So, on a flat Earth, when people say, "Oh, gravity! Look, I'm just gonna drop that and jump out of a window, stupid flat earther, and test gravity." Well, you're testing buoyancy and density, but the question is, buoyancy and density sort things out, right?
Yeah.
So here, I have a thing. Where is it? This is, So here is that. Let me fix that. So here is a blimp, right? Have you looked into old world blimps yet? Oh my Lord. Old world airships. Whole nother story. This blimp is less dense than the air. The ship is less dense than the water. And the submarine is more dense than the water. But the question is, what makes everything go down? Right? What makes things, what tells it down is the down direction. And my answer is electrostatics. I'm going to show you a little scientific experiment. So here we have some leftover helium party balloons, and we tied it. We got just like a little button here we taped to the end of this wire that goes to a Van der Graaf generator, which can generate a static charge. And we're going to add a positive charge to this. And when we add it, it goes down. Why did it go down? Is it gravity got stronger, or it's attraction to the negative charged Earth just got stronger? And when you discharge it, it goes up. So
that's awesome.
That's a little experiment we did there. Here is one where we put a negative charge into it. Excuse me.
Oh, what is that? That's a what's that?
We just got a tinfoil triangle here, and and it's light, and we're just putting a small negative charge into it, and you keep the charge in it, it goes up. So negative and negative, whoosh, they push away. Huh. So are we changing gravity, or are we just messing around with electrostatics? It's clearly, obviously, provably, no argument that we are messing around with electrostatics, which are somehow overpowering gravity.
Have you looked into the pyramid technology as far as that and the what do you call it? It spins like vortexes and the ley lines. And do you think that is connected to that? Because from what I understand, it's more of like an energetic flow, which is a push and a pull, energy flowing into the Earth and energy flowing out of the Earth or the plane.
Yeah. So that is a big part of it. Here is just another more real world example. This is MIT thing looks like a milk crate or a skid, and it has no moving parts. It's using electrostatics to fly. It's got no moving parts. Now, scientists will say, well, it's using the ionic flow. Yeah, what about ionic flow? There's no wind coming out of that thing, right? It's pushing ions and you can't see them. Because they have to make up something to fit with the gravitational model. This is just electrostatic propulsion. The SR, not the SR, sorry, what's that triangle aircraft, that secret aircraft they talk about?
Yeah.
The TR-3B or something like that.
Exactly. Yes, I think that's what it is. Yeah.
And they talk about how it uses electrostatics for lift and propulsion. Right, so the knowledge is already out there. Glenn Beck just did had a scientist on that said that they've discovered this electrostatic propulsion in a new way that literally cars in the future won't need wheels. Glenn Beck's freaking out over this thing, right? And they're like, yeah, but it breaks the laws of physics. It certainly does if you believe in gravity.
Well, it breaks the current existing laws of physics.
Well, yeah, these aren't laws. These are belief systems in a theory.
Guidelines, right?
Yeah,
guidelines and theories.
Yeah. So here's the funny thing about electrostatics, right? So NASA, not NASA, mainstream science says that electrostatics are 10 to the 36 power stronger than gravity. Can you conceive of what 10 to the 36 is?
It's a lot.
Well, a lot. That's an insult. That's an insult to the 36 power. So a trillion is, well, let's talk about how big a trillion is. 1 trillion. Now we have a number of trillion. We're at $71 trillion in debt. This is a $1 trillion deficit. Whatever. People like trillion. Okay, billion, trillion. What's the difference? How long is 1 trillion seconds?
Like 1,000 years or something like that, like something insane.
31,000 years.
That's
okay.
That's 30 times more insane.
31,000 years is 1 trillion seconds. I say this on a lot of podcasts, and people that are hearing it again, you need to hear it again and again and again because you don't understand. 31,000 years, I don't even think the Earth has been around that long. Okay, but 31,000 years, that's 10 to the 15th power. If you added 3 more zeros to that, that's 1,000 times that. Right?
It's just a lot.
We got to do that again. We're not even halfway there yet, 10 to the 36. Right? Times 1,000, times 1,000, times. You can't fathom this number. So, that's what they say. Electrostatics is 10 to the 36 power stronger than gravity. Let's pretend gravity is real. Okay? So, electrostatics is pulling this ball down 10 to the 36 times stronger than gravity. That means, and it's a weak force, right? The electrostatic force is pretty weak. That means gravity is 0. 10 to the 36 zeros, 0.36 zeros. Maybe I'll give you a 1 after that. Maybe. If it was real. That's 0. That's 0. So how can you say gravity is responsible for any of this when it's go prove your gravity. Do a scientific experiment like I just did, showing you electrostatics manipulating things going up and down. Explain to me why during electrical storms things fall at different rates. Explain to me when.
Which is interesting. Yeah. That will be a huge tell. But then in an electrical storm, you have a different density of air too.
Well, right. I mean, but sometimes when lightning strikes the ground, people and things right next to it go flying in the air. Did it change gravity or did it change the polarity of the Earth for a split second?
That's interesting. Yeah. Or maybe that's how, like that movie Twister, where you have cows flying around in a tornado, right? And just messing up with the electrostatics.
Electrostatics, right? Is it really the wind lifting it up, or is it the electrostatics?
That's actually, that's another aspect of it, because it's an actual real thing. But I'm like, how does the wind pick up an animal? But I've seen it destroy stuff, and the force of it is insane, right?
Yeah.
But it does make more sense that you have it's just layered on with electrostatics. But there's sacred geometry. Are you familiar with that?
Oh yeah.
Where you have the understanding or the theory that our solar system is based off of frequency, vibration, and that's what keeps all the planets in place. Each planet has its own geometry, and that's where all the, I forgot the names of it. Like, let's say I think it's a dodecahedron, and all the vertices of the dodecahedron on, like let's say like you overlay a dodecahedron onto a planet. Like, let's say in this theory, the sphere, and the vertices that touch the landmass are the vortexes, and they found that to be true as far as that matches up. How do you explain that? I mean, like that's one theory, and it helps with understanding when you go down and you really dissect a lot of matter, right? Which is just mostly energy. You see these geometric shapes, and that also coincides with cymatics. And I'm wondering if you ever had a conversation around that stuff.
Yeah, that's a whole nother topic. That would work on a flat Earth and a globe Earth. I don't see any difference, but the flat Earth is, you can't live on a globe Earth in a space vacuum without a container. You can't contain air, without a container. Gravity's holding the air down, but I can suck air away from the ground with a straw with the weak, not even, low pressure of my lungs, but the Tor 17 vacuum of space can't pull the air off of the Earth. It's all crazy. I love the cymatics thing, but that's a whole nother show. A
Sure.
whole nother show of stuff.
That's when you come back.
Yeah. Why we're talking about you're just talking about tornadoes, right?
Yeah.
You ever seen a tornado in person? Well, you've seen the destruction power, right?
Yes.
And a tornado is like 300-mile-an-hour winds. 300-mile-an-hour winds, right? That's crazy, right? And what temperature is it when there's a tornado? I don't know, normal temperature. It's room temperature. We'll just call it room temperature. It's cold. Yeah. It's tornadoes usually happen in the summer, so we'll say between 60 and 80 degrees. Okay?
Okay.
So if you had a 50-mile-an-hour, 80-degree wind blowing at you, kind of feel pretty
Fahrenheit.
Cool, right? Blowing your Fahrenheit. A hurricane, a 200 and my father lived down in the islands, and they had Hurricane Hugo, 220 miles an hour. It blew almost every house off its foundation. Okay, that wasn't cement, and 220 miles an hour. That's crazy. A tornado, 300, maybe 350. It pulverizes trees. It ties metal poles in knots. Right?
Wow.
It does everything, and that's at room temperature. What would happen if you had a 600-mile-an-hour tornado, a 1,000-mile-an-hour tornado, a 10,000-mile-an-hour? You can't fathom this, just like 10 to the 36, right?
That's what they're saying that is going on in Jupiter. Like, it's just
yeah, it's crazy. So this is the space shuttle, okay? Right? This thing goes over 17,000 miles an hour. It weighs 4 million pounds. The thrust coming out of here, the flames, are a little bit higher than 80 degrees Fahrenheit. And it's coming out at 20 or 30,000 miles an hour to get this thing up. Okay? These people are 11 miles away, but they want you to make it look like they're right there. And watch what happens to this fence when it takes off, okay? First, this fence right here doesn't shake.
And for anybody listening, there's a fence right next to it.
Nothing happens. Nothing happens. Everything would be obliterated. That's 20, 30,000 miles an hour superheated flames. Everything would be pulverized and vaporized. Nothing happens. I'm showing the shuttle taking off. You really got to watch the video on this.
Yeah. Highly suggest watching the video. But so, I mean, with my global thinking cap on, well, there's scientists that work at NASA. They did the math. They know the materials to build the facility and to make sure that doesn't happen. Of course, it won't happen, because then it wouldn't. They went through that already.
Show me the science that that can withstand 30,000 mile an hour superheated thrust. Show me the science of a satellite that's in the thermosphere that's handling degrees of 3,000 degrees where it doesn't melt. What metal doesn't melt at 3,000 degrees? Right? Show me the science of high pressure next to zero pressure without a container. Right? And if you talk to people at NASA, we've talked to many of them, and they say they don't know what the person next to them is doing. Everything's so compartmentalized.
That part makes sense.
Yeah, and there's people in NASA that know. There's also many people in NASA that don't know.
Now, do you know anybody in NASA?
We've interviewed people, and they're like, "Well, my job was this. I make these parts, and then they go here. And I don't ever see that. Like the guy that runs the Hubble, the head guy for Hubble, the telescope in space.
Yeah,
we had one of our guys got him on the phone, and he's said he was a research student. I think he was at the time in college, and he was talking about the pictures that the Hubble took, and the guy is talking about it, and the guy realized he never has seen the Hubble. He's only gotten data. The head guy in front of Hubble has only gotten data, right? This is the Hubble, right?
yeah.
Looks to me like a garbage can wrapped in tinfoil, but that's a whole nother story, right? And our guy had done some research where he found some pictures from they have a telescope called Sophia, and the Sophia is mounted in the side of a 747 where it has a big hatch that opens up, and it can film things out in the sky. I don't want to say space because space is fake. And they were the same pictures that Hubble was getting. And the guy that runs Hubble didn't know this.
Huh.
He didn't know
That's
that.
actually
So
kind of sad.
The head guy for Hubble did not know what we were showing him. This isn't theory. So
who's showing him? Like someone is beyond him telling him what to organize.
True. But they release these pictures from they. Here's the thing. Here's the beautiful thing. Whether they're stupid or they do it on purpose, because I'll call it revelation of the method. They always tell us the truth. It's whether we're smart enough to see it. They always tell us what's going on, and the question is, are we smart enough to see it, right? Here, just since we're talking about Hubble, this is a couple of years ago before the James Webb. This is the new Hubble photograph they got. Look at it real careful, right?
Okay.
And then here's the old one. It's the same photo.
Just at a different angle?
It's just the same photo. It literally, when you zoom it was hard to see from what I showed you. It's the same photo.
Oh, so you're saying that they zoomed in. Go back real quick.
No, it's just the same. It's just the same nonsense photo. It's just literally, it's a garbage can. It's literally a Del Monte beans wrapped in tinfoil, right, with little wheels from a balsa wood, airplane that we used to fly, right? It's the dumbest crap ever, and people are like, oh man, that's a $30 billion telescope. Yeah. It's so silly, right? And then they show us, they dazzle us with images. Oh, this could never be created on a computer. This is from Hubble, looking at something light years away.
All the images of Pluto and Saturn and the fact that they get clearer as we get, as time goes by, you think those are all computer generated? So
not even computer generated. Many of them are just painted, right? Many of them are just painted. So here is this is a new picture of Jupiter. Wow, look at that. That's. I mean, I couldn't do that by putting some watercolors in water and spinning it around, right? And people will believe anything. Like, what planet is this? Do you know?
That's Jupiter.
Is it?
I mean,
if I zoom in on it,
unless it's
Saturn. Actually a meadow with ducks. Okay, what I'm showing you is how easy it is to fool people. I was fooled by it too. Don't feel bad. Okay, when I saw that, I'm like, yeah, it's obviously Jupiter, obviously, right? And this is what they have at NASA. This guy literally painted Jupiter and they use it NASA has one of the biggest green screen studios in the world. Why? Right? So this is at NASA. And they have tracks for cameras that go around it. And they have fake moon and everything, right? This is the famous picture from 2014 that this is the picture of Jupiter. It's from that, right? And then in 2016, they said, we filmed the Northern Lights on Jupiter.
Photo.
We filmed the Northern. Look at this.
Yes.
Look at that. Northern
You know
Lights.
what? Yes,
Okay, go
that
ahead.
brings. I had that reminds me of that I remember seeing photos of Jupiter, and you see the huge eye, and the eye always looked the same, and I was wondering, I'm like, how is it a storm, but then it doesn't change, and how
Right.
is it? They're just recycling the
These
same
these two
photo?
pictures over 2 years apart. Every cloud is exactly the same.
That's freaky.
Every
Again,
every cloud
obviously the same photo.
every cloud is exactly the same. Obviously the same photo. I'm just trying to. I have but they'll be like, well, it's so big, the storm, hardly moves, and whatever.
Right.
Um, where is Oh, and then that way, I'll show you this real quick, and then we'll go back. This is NASA just released this recently of the moons of Jupiter. Look at this.
It's a video.
This is a video. This is from NASA.
That definitely looks like CGI.
You think? You think? Well, flat earthers say everything's fake, so you're welcome to the club. They accuse us of saying everything's fake because everything is fake, right? So this is NASA. This is whether it was over a couple days, couple hours, a couple weeks, doesn't matter. Here's the storm. It's spinning. You got counter rotating, storm tracks.
Right.
These are clouds. How is every friggin' thing the same? This was shown to us in like 1970 or 80, whatever it was. The Voyager was going by. Right? That just completely debunks what I showed you. They showed us the exact same images. And then think about this. The Voyager then at 60,000 miles an hour went by Pluto. Right? Pluto is so far from the sun that the sun looks like a tiny little star. How does that tiny little star light up Pluto? So bright that we can get a photo of it traveling at 60,000 miles an hour and then send that back with 1970s technologies to Earth and get this photo.
I see Pluto the dog. I see Pluto's head.
This is the actual image from NASA, and it looks like Pluto the dog. That's just a coincidence. That's pareidolia, right? We're just imagining things, right? We're just imagining things.
No, yeah, that could be coincidental.
And then
it could have been inspired.
recently, they get this new picture of Pluto. Look at this. What the heck
beautiful.
is that? It's not even a sphere. Like this is just. Did they have a fifth grade contest? Hey, make a planet, right?
Yeah.
Right.
Well,
Did you see,
nowadays you see more color.
I have a question for you. Are these planets from NASA?
Now I don't trust it because the last one was a meadow. So now I'm like the bottom right. He's showing me an image of like 3 different planets.
Yeah, these are actually frying pans. Okay, these are all the bottoms of frying pans.
Oh, that reminds me. I have an image.
Yeah.
Those the street artists. They have like aluminum foil, and then they use the spray can, and they make planets.
Yeah.
Off of dabbing the aluminum foil.
It's
and I'm
so
like, wow, it's
easy.
so amazing. It looks just like it.
Check this out. Now, NASA discovered a new Earth-like planet, okay? It's amazing, but all the land is on the bottom. It's pretty cool, and, here's a video of it. Or is this just a guy in his shed with a fisheye camera filming an old propane tank?
Oh, that's annoying.
Okay? I'm just saying, NASA gets $80 million a day for what?
That's the budget?
$80 million a day, every year, all day, all weekends, all holidays. $80 million a day. What do they give us? Oh, we're in space. We're doing science. On my channel, DITRH, my main YouTube channel for my short videos, for those of you that are just like, what? Flat Earth nonsense. My latest video is NASA and the Olympics. They had on the ISS, they were pretending to be in the Olympics, competing in zero gravity. It is the stupidest thing you've ever seen, okay? And this is what they're doing up there. They're playing games. $80 million a day. $80 million a day.
Well, the acronym that I think is funny with NASA is never a straight answer.
Not a space agency.
Okay, I like that one too. That's funny.
There's a whole bunch.
Okay. Oh,
Yeah.
so you have more. So you have more planets on
No,
here.
no. The last thing is, this is what NASA gives us, and then this is what all of our super zoom optics give us. Hey, what are these things? I don't know. They're all named after gods. Okay. Mm-hmm. Interesting.
And it looks like the reflection off of water when something's in the water.
Yes. Now you've seen some of that. We have one guy on TikTok. He's got great, incredible telescopes. He's an amazing guy, and he zooms in on the moon perfectly in focus. Then he zooms past the moon. Moon goes out of focus.
Right.
Then he zooms back in. Moon's in focus. He zooms before the moon. Moon's out of focus. So he's showing that he can zoom in on the moon to a focal point.
Right.
He could do the same with a planet. He could do the same with stars. But then he could zoom in on any one of them and move the camera from one to the other, and they're all in focus.
That's freaky. Okay.
Yeah, which is crazy. But when we look at stars through today's consumer optics, this is a burning ball of gas, countless trillions of miles away.
So let's get into that because you keep bringing that up, and I want to make sure we hone in on that. There's that, and I think this can also coincide with the horizon. As things go further away, they get smaller. And I think you have an answer that's similar for both, where you have the boat as it goes out to sea, and then the horizon, it disappears from the bottom up. And if it was flat, the whole body would get smaller and smaller and smaller.
Yes and no. It depends on the atmospheric conditions, right? So think of the Earth, flat or globe. It's got its layer of atmosphere. You're down here on the Earth.
Right.
When you're looking up, you're seeing through this much atmosphere. When I'm looking that way, I'm seeing through maybe 2, 3, 4 times that amount of atmosphere. When I'm looking straight across, I'm looking through infinite atmosphere. It's all atmosphere, right?
Okay.
And
On
so
a flat
atmosphere
plane.
on a flat plane, it would be, just draw a line. There's your flat plane. Draw a line above it. That's the top of your atmosphere. And then
Yeah.
look up, look 45 degrees, and look to the left, right? So it's going through infinitely more. So as the sun goes farther away, you're looking through more and more atmosphere. So that atmosphere, when it has moisture in it, is magnifying it. So it's getting smaller, but it's also getting magnified. This is a beautiful place we live in, right? Here's a pretty dry day. And the sun, when you're watching the sunset, are you falling over backwards faster than the speed of sound? Or is that sun just moving away and taking its light with it?
You wouldn't be falling over because
If you're on a globe,
gravity.
and you're watching the sun, you're falling over backwards faster than the speed of sound. You're not falling. You're spinning backwards on a ball.
Yeah, yeah.
So when you're watching a sunset, these people here are falling over backwards faster than the speed of sound, which is making the sun appear to go down. Or is that sun just going away? And look, this is the soup of the atmosphere. It becomes opaque. It becomes opaque over distance. So the sun just goes away. And sometimes it gets smaller. Sometimes it gets magnified, right? Here's the sun. Now this one is, this is one where, is this a lens flare? What are we seeing here? That's a whole other topic. We don't have time for it. We'll do it in the next one.
That video is you have 2 suns in that video. And that could be something else. Yeah.
Yeah. So that's a whole nother thing. Here is just to show you perspective. Street lights on a level street, they look like they're going down. The sun, it looks like it's going down. It's just perspective.
Interesting.
So here is so I set this up. This line here is level, and I'm looking at it from a celestial point of view. This is the same line. A little hard to see. That's level, but I'm looking at it from the countertop.
So this is your
This is
experiment at home.
this is my flat Earth kitchen. So this line is just the sun is just going away, and it's going beyond. It's a little hard to see. There's like a piece of cardboard here. It's just this is staying above it, but from this point of view, it just looks like it's going down and below it. This is the actual sun. It's going away, and it's going behind this atmospheric deck of opacity right there.
So the bottom, you're saying the bottom disappears first because of the atmosphere?
The bottom, because of the atmosphere and because of land, anything like in the distance, 100 miles away, there could be a mountain that you can't see. The light coming off that mountain can't push through the atmosphere, and it just becomes opaque sky. But when the sun goes beyond it, I'm going to show you that in a second because that's a big one. How the sun sets is very, very, very important. So here, I'll show you right now. Here's the perspective. You know how we're taught how everything from the sides go in, the top and the bottom, everything goes to a vanishing point. We're taught that in art class.
Yeah.
Okay. They also don't teach you that the back to the front gets compressed also. Right?
Huh.
The back to the front. So like if I counted 1, 2, 3, 4, 5, this is 5 spaces right here. This amount of space.
Yeah, as you get close in.
So the next 5 are tighter. The next 5 are tighter. The next 5 right here, like from here to the end, there's probably another 50 squares, but you can't see them because they're getting compressed forward to back. So here I got a guy. This is his eye line. This mountain, we'll say it's 3,000 feet above his head, and you got the sun above the mountains. All makes sense. The sun moves away. It goes beyond the mountain. Now, is it below the horizon or just beyond the mountain?
Beyond the mountain.
Right. Now, two ways he can see it. He can float up in the air and look over the mountain and see the sun, or he can go backwards. So if we put him backwards and we move that mountain 20 miles away, the sun is right where it's supposed to be in the sky. But the mountain has lowered. It looks like it's at his eye level. It looks like it's horizon. But whether the earth is a globe or flat, this mountain is still 3,000 feet over his head. Right? If it was a globe and you wanted to count in curvature, okay, take 400 feet off of that. Okay? It's still, thousands of feet above his eye line. And if you move the sun farther away, is it below the horizon or just beyond the mountain again? It's beyond the mountain.
Yeah.
Right?
Okay.
So now we add the sky level. The sky layer. There we go. That's the word I'm looking for. You got the cloud deck, which is above the mountains.
The cloud deck.
The cloud deck.
It.
You've seen the cloud deck, right? Where
Yeah.
the level the clouds are at. And they all merge into this line also. So here we have another line. This line is the clouds merging into the same line as the mountaintops. So the sun is above the clouds. It goes beyond this line. This line is the atmospheric deck, which is thousands of feet above the mountain, which is thousands of feet above his eyes. So this horizon, the horizontal eye zone, is not at his eye level.
Slick.
It's above his eye level. Things go beyond it.
I love how you have this whole presentation set up. You're ready. Okay, I got it.
It's Flat Earth 101, my friend.
I love it.
Flat Earth 101.
Because
because this stuff is fascinating, but they don't teach us. They tell us something, and guess what? If you want to be a teacher, memorize and regurgitate. Don't ask questions, and you can be a teacher.
Yes, and that's a whole nother show as well, as far as the history of our schooling system and how it's bought and paid for. Yeah, I that whole thing. That's why I'm open-minded, because a lot of what we are taught, especially nowadays, people are more open-minded than ever, and now's the time to ask these questions, whether you're whatever your belief structure is. That's why I really appreciate this conversation and the fact that you put so much energy and time into the explanation of it.
Right.
With the graphics, with the visuals. That's why I'm
the visuals are important. I do non-visual, audio only podcasts and in person. I just done Roseanne Barr, as I mentioned earlier, I think.
Yeah.
Check out her podcast. It's really a good one, and she's blown away.
Yeah, leave this one. Just leave this one and just go to that one.
No. When you're done, if you want to see another one, because I don't expect people to give up their ball. Nobody wants to let their ball go. Okay, right?
Especially if you're a guy.
Yeah, no one wants to let. Everyone loves. Everyone. I don't want to say it. Balls. Everyone loves balls. All right, I said it. Okay, I said it. Let me just show you another thing also, which people go, oh, I've never seen that. The Globe trolls absolutely freaked out when I presented this, because it happened several times. So This is what I call the sun fade out. Excuse me. So the sun is up in the sky, and if the Earth is rotating, it would move at the, they say 15 degrees per hour, 360, degrees around, right? It would go down, 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 and it would never stop. It would just keep on going, and it would set. That's what the globe dictates, right? But it didn't. It went down, 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 and it stopped. Super clear day, 32 degrees, no humidity. My drone's up super high, and I'm filming this. My friend's at the beach down over here. It's nighttime already. The sun already set from the bottom up 10 minutes ago, and I'm still looking at the sun. Now, whether it's in focus or not doesn't matter. It stopped, and this is super sped up. It sat here for 10 minutes, and I'm watching it going, what the hell? What the hell's going on?
Oh, that's weird.
And its light could no longer push through the atmosphere and get all the way to your eyes. So I'm just going back and forth here. It takes its light with it. It takes its light with it.
Did you research like the lens and its capacity to hold on to light and all that stuff?
Well, the Globers will say, put on a solar filter,
Yeah.
right? I'm not talking about the glare of the sun. And by the way, I did it again. I put on a solar filter, and it's black. There's nothing there. Landed the drone, took the solar filter off, put it back up. There's the sun. Okay? What basically they're saying, put on a solar filter and blind yourself so you can't see the important part of a sunset, which is the last part when it gets down to your apparent eye level at your horizontal eye zone.
That's freaky. Okay, so since we're on the sun topic, let's go into the eclipse. I have other ones. I definitely want to get to Antarctica. I know that some people are wanting to know about that, but let's...
One more here, just real quick.
Okay.
So on a ball, there's a physical amount of curvature, right? So you can't see my mouth because it's behind a physical curve. Zooming in isn't going to help. It's behind a physical curve. So there's limitations on a ball of how far. So here's a spot in Canigou, France. We're looking out, and out here, 175 miles away is Mount Canigou. Can't see it because the globe math says the top of that mountain should be almost a mile below the curve. Okay?
Right.
The top of the mountain should be a mile below the curve from this viewing spot. Well, you don't see me. You see the light that's bouncing off of me. I could prove it, turn off all the lights in this room, and you won't see me anymore. Right. You don't see the mountain. Globers say because it's behind the curve. We say it's because the light that's bouncing off the mountain doesn't have enough brightness to push through 175 miles of curvature. I mean, of atmosphere.
Also, the last video you showed the sun fading out. So that coincides.
Well, that's a little farther, but this is it. The sun's light can push through 175 miles, and as it goes beyond, not below, the mountain, it backlights it, and here's the mountain in its full. The top of this mountain should be over about a mile below the curve.
Based off of the curvature math.
Based off the curvature math, and the Globers say, well, actually, the sun has already set. It's refracting up. And the mountain that has no light on its backside is also reflecting up, blocking the refracted sun. Okay? If your mind didn't follow that, it's because it's stupid. All right? It's stupid. You're not stupid. It's stupid. Okay?
Yeah.
If you can't follow something, it's not because you're stupid. It's because what they're saying is stupid.
Actually, that reminds me, and don't judge.
Oh, I'm judging.
When I used to work for a cell phone company, I used to be a tech, and people would bring in their phones, and it's having this issue and that issue. And if I didn't have an answer for them, we would joke around, and we would say, oh, it's the flux capacitor stopped fluxing. And you would just throw something at somebody just to have them give up. That's why a lot of our technology, it's smart this, it's smart that, because people don't want to spend the time to process how the tech works. So it's the refraction. It would be great to look into that and understand the science, because someone spent the time to break that down.
Let me tell you,
wouldn't be surprised if it's something similar.
It's so fun to be a Glober because you can just make up stuff. So when I first looked into flat Earth, and then we'll get to your question. I started seeing, I bought a super zoom camera, and I'm seeing things that are below the curve. I'm like, that's impossible. I said, the curvature formula must be wrong. So I went to the debunking sites. And on the main debunking sites, they have a curvature calculator. It says, okay, put in your elevation height, put in your view, your observation height, the how far this thing is that you want to see, how tall it is, and it'll tell you what the curvature is, how much of it should be blocked. So it's like, okay, 100 miles, I want to see something that's 2,000 feet tall, and my viewer height is 6 feet, 3 feet, whatever you got, and it says, 3,000 feet should be hidden, but I can see it, right? So it says, okay, then there's another knob. It says, it's a refraction knob. You slide it over until you can see it, and then you say, that's how much refraction there is. Okay? It's the magic refraction knob. So somebody recently just went on there and said, okay, my observer height is 10,000 feet. My observation is 24,901 miles away. That's the full circumference of the Earth. Mm-hmm. And so he slid the refraction bar until he could see an object 6 feet tall at that distance. And it told him what the refraction is to see the back of his head. Okay? And they want you to believe, just because you got a calculator that has a magic refraction slider, just because math is right, I can show you math is right that proves a flat floor is a sphere, right? I can do math. Math is not reality. Math describes whatever you want it to describe. Right, go ahead.